Welcome to all the Honors Algebra 2 students, whether you're my class or Mr. Clendenin's. Welcome. I know that you guys did parabolas and circles with Mr. Clendenin already this week, and what we're going to do now is we're going to kind of go to the next conic section called ellipses. Now, you guys have a 3-page PDF that has been shared with you. The first page called the ellipse fact sheet. I'll be referring to that. So if you have a printer, you can print it off. If you don't have a printer, you should write that information down because I'll keep referring to it. So you should have it handy so you can kind of go back and forth and know what I'm talking about. Also, if you have a printer, you could print off the notes and the homework as kind of like guided notes in the homework. You could do it right on there. If you don't have a printer, you can just write them down. Obviously, I don't have any grids or graphs here, and then I can make it work. All right, so we need to know the ellipse fact sheet or the information on there, but I'm going to break down the information as I go through each problem. So this is what we call the nice center form, okay, of an ellipse equation because it's basically two fractions with x squared and y squared on the top equaling 1. Now, from that, the first thing we do is we want to find the center of our ellipse if we're going to start graphing it. So I could draw my x-axis and my y-axis, and I can put this center dot first. Well, since it's x minus h and y minus k in the fact sheet, you do the opposite after x and the opposite after y for your center. Well, there's nothing after x, so h is 0, nothing after y, so k is 0, so my center is 0, 0. And you can write that down. So you can say, all right, so the center, I usually abbreviate it, CEN, is not equal to, or you could put that, but it's 0, 0, or the origin. Now, the next thing is, what do your denominators mean? The denominator underneath x was labeled a squared, so you do have to square root it for your a value. Since this is a squared, a would equal 3. Now, we don't really put the plus or minus because it's a distance, but it is your horizontal distance, or half of it, because you go a spaces right and a spaces left. So from this dot, I would go 3 spaces right, 1, 2, 3. That is a vertex of an axis. And 3 spaces left, 1, 2, 3. And that is a vertex of an axis. Now, it's a vertex of an axis, but I didn't say if it was major or minor yet because I don't know which one's longer. But I will know really soon. Since the denominator underneath y is b squared, I have to square root him. So as I square root 64, it's plus or minus 8, but since it's a distance, I only say positive 8. So b is equal to 8. Now, if I'm going to count 8 spaces up and 8 spaces down, I know that that must have been my minor axis. So right away from your equation, you should know, is your ellipse elongated horizontally, or the major axis runs this way? Or is it elongated this way, vertically? Your major axis runs up and down, and it's by which denominator is larger. So I will have to go 8 spaces up, 1, 2, 3, 4, 5, 6, 7, 8, put a dot. 8 spaces down, 1, 2, 3, 4, 5, 6, 7, 8, put a dot, and that's the vertex of my major axis now that I know that. And I could try to connect all 4 vertices with this nice, smooth, oval-shaped thing called an ellipse. So, from the equation, you should be able to get your center first. Then you should be able to tell how far left and right you count, how far up and down you count, making your major and minor axis. Again, the major axis in this one is vertical, the minor axis is there. One thing that is tricky for kids, neither of these numbers represent the major or minor axis. You would have to double them. So the major axis is 8 up, 8 down, so this would give me a major axis of 16 units long. The minor axis, 3 right and 3 left, this would give you a minor axis of 6 units long. All right, let's look at number 2 and see how we can use that same information to graph this ellipse equation. Well, the first thing I notice, it doesn't look like the nice setup. It doesn't have fractions and it doesn't equal 1. So how do I turn this into the center form? Well, if I want that to turn into 1, I simply divide both sides by 100. So I'll divide by 100, that makes 1, but if I do it to the right side, I do it to the left, and I have to do it to each piece of the left side. So divide by 100, divide by 100. Now, it would not be nice if these fractions don't work out to be like a nice 1 over something, and we're not going to get into those this year. But so yours will always be like 1/2 or 1/3 or 1/4 or something like that. Well, 4 over 100 represents 1/25. So I keep the x plus 3 squared on top, and the 4 over 100 reduces to 1, which is invisible, over 25. Then there's a plus sign, fraction, and I have 50 over 100 is 1/2, so I have quantity y minus 2 squared over 2, representing 1/2, equals 1. Now I am ready to graph that ellipse, getting all my information from the ellipse fact sheet. So again, if you don't have a printer, no big deal. Draw an x-axis and a y-axis like I just did. All right, first thing we find is the center. The center, you guys, is the opposite after x, comma, the opposite after y, because the equations is x minus h and it's y minus k. The minus makes us do the opposite there in the equation. So the opposite of plus 3 is negative 3, comma, the opposite of minus or negative 2 is positive 2. So my center is negative 3, comma, positive 2. Now I'm not going to put all the tick marks, but if you had a grid, you could obviously count off correctly. Now, what I'm going to do is know how to move left and right and up and down by my denominators. And I should already know which way this is elongated. Is this a horizontal ellipse or a vertical ellipse? It's where the larger denominator is. Since the larger denominator is underneath x, it will be a horizontally elongated ellipse. So we take the square root of 25, which is plus or minus 5, but it's a distance, so I'll only use positive. So I'll move 5 spaces left and right. Remember, that would make a major axis that is 10 units long. But if this is negative 3 or 3 spaces left, I'll go 5 spaces right, which puts me over there, and 5 spaces left, which puts me here. Now, if I really wanted to, I could plus 5 and say this vertex is 2, comma 2. And when I go left, I minus 5 to the x number, so it'd be negative 8, comma 2. I could label them using what I already know from geometry and earlier stuff in Algebra 2. Now, here would be the tricky part here, is 2 doesn't have a nice square root. You could keep it exact and keep it as b is equal to the square root of 2, or just to help us graph, we could round, so it'd round to 1.4. So from that dot, I'll go 1.4 up, and I'll go 1.4 down. Now, if you don't have a grid, you should still know your spatial awareness. The center was up 2 spaces. So when I go down 1.4, I am still above that x-axis. Now, you guys, you have your 4 vertices. You have your 2 vertices of your major, 2 vertices of your minor, and you can make this ellipse like so. All right, you can pause it right now if you don't have everything written down before we do our last example. We should be able to write the equation of an ellipse if we're given information about it. But the number one thing that I would say helps me out at least is when I'm given information, I draw it. Okay, any information that I have, if I draw the information out, it just makes it a little bit easier for me to understand. So number 3, if you looked at your PDF, there's more words. I'm just going to write down the important information. So we're going to write the equation of an ellipse that has a major axis length of 20 units. All right, so the major axis is 20 units long. Now, by that information, I really don't know if it's 20 spaces total horizontal or vertical yet. I'll have to figure that out by some other information. But it says the minor axis vertices. So the minor axis vertices are at negative 4, comma 8 and negative 4, comma negative 4. Well, if I plot these minor axis vertices, then the major axis runs the opposite way. So again, so that's kind of like how I'm interpreting this information. So a graph really helps me out. It's not necessary, but it is helpful. So I'm going to graph these first. Well, negative 4 comma 8 is up here. Negative 4 comma negative 4 is down there. So if this is my minor axis that runs through these dots right here, my major axis must be horizontal. But I really can't use it yet because everything from the major and minor axis, when you count spaces, comes from the center. But luckily, we should be able to find the center of these two ordered pairs. And to find the center is the midpoint from geometry, but it's just the average of the numbers. Well, obviously the center is on that vertical line, so it's negative 4 comma something. So this would lead me to know that the center is negative 4 comma. Well, the center would just be smack dab in the middle, or the average of those two numbers. So if I took 8 and negative 4 and I average them, I add them and divide by 2. Well, 8 plus negative 4 is 4, divide by 2 is 2, and negative 4 comma 2. What you can do to double check your work is make sure it's the same distance away from each one. Well, if I go 2 to 8, that's up 6 spaces. And if I go 2 down to negative 4, that's down 6 spaces. So having a center at negative 4 comma 2 would make sense. Up 6, down 6, that's definitely the center. So with that's the center, I can do my numerators of my equation right now. If you get out your fact sheet, your setup looks something like this. Well, behind x is minus h, and that means that in order to get the center, you do the opposite after x. So if you minus h and you minus negative 4, that becomes plus 4. And if you minus k, well, minus 2 would just be minus 2. And again, you could double check the opposite of that, yep, and the opposite of that, yep, for my center. Now, the only other thing I really have to do is figure out my denominators. Well, that is, again, how far you're moving, left and right, or up and down. Well, if the major axis is 20 units long total, that means you would go 10 spaces right and 10 spaces left. Now, that would make my horizontal ellipse because 10 is larger than 6. But if that's 10 and that's 10, I know my a value is 10. And this denominator is a squared. So 10 squared, 100. Okay, now we already knew, or I've talked about it, is up and down was 6 spaces up and 6 spaces down because the center to those vertices. So my b value is 6. But the denominator is b squared. So I have to take 6 and square it for 36. And that is the equation from the given information. All right, you guys, you could rewatch these videos. Again, reach out for help to Mr. C or me by Google Hangouts, email, whatever like that, and we'll help you out. But hopefully these 3 problems, along with your fact sheet, will allow you to do the homework problems. Now, they are in the PDF form. It's the 3rd page. So I'm not going to show you on the video today. If you don't have a printer, you could write them out. If you do have a printer, you could print this off and do your work straight on there. Take a picture of your work, though, no matter how you do it. Upload it to the Google Doc. Send it to me or Mr. C by tomorrow morning. Have a great day, and I'll see you again tomorrow. Bye. It's your boy, Mr. P.